squared, add those together, that will be equal to c squared. First problem, using Pythagorean theorem. Given a triangle with two sides of 3 and 4, we can find the missing side, which is c. Pythagorean theorem again, you take each of the two short sides, the two sides that are connected by the right angle, and we'll square each number. 3 squared would be 3 times 3, which would be 9. Adding to that, the other side squared, 4 times 4, which would be 16, and that's equal to the side that we're finding, in this case c to the second power, or c squared. Adding 9 plus 16 would be 25. And to solve for c, to get rid of the exponent 2, we can take the square root of both sides. The square root of 25 would be 5, and the square root and square would cancel, so we have the answer of c equals 5, or 5 equals c. There's no units given in the problem, so there's no units for the answer. Second question, and last question for this section. Again, we have a right triangle with a right angle. The two short sides are 5 and x, and the long side, called the hypotenuse, across from the right angle is 13. Using Pythagorean theorem, you can take either of these short sides first, 5 for example, and square 5. 5 times 5 would be 25. Adding to that the second side, which again is touching the right angle, in this case is x, squaring the x would be x squared. And that's equal to the longest side, the side across from the right angle, 13 squared, which would be 13 times 13, and that's 169. To solve for x, find the missing side. We want to get x by itself. We have to first get rid of the 25. Opposite of adding 25 would be subtracting 25 on both sides. And we'll have x squared equals, subtracting straight down, 9 minus 5 would be 4, 6 minus 2, and the 1 comes down. X squared equals 144. And again, to get rid of a square, we can do the square root. The square root and the exponent cancel. X equals the square root of 144, which would be 12. So the length x, one of the sides in the triangle, x equals 12. Area of kites. A kite is kind of like a diamond shape where the diagonals are perpendicular. A diagonal is the distance from one corner to the opposite corner. So the two diagonals being perpendicular means where the two diagonals cross. Perpendicular means it makes a right angle or 90-degree angle. For the area of a kite, the formula would be 1/2 times d1 times d2. d1 is the length of the diagonal, so the distance from one corner to the other corner, times d2, which is the opposite diagonal, the distance from the other corner to the opposite corner. Multiplying by 1/2, again, is the same as dividing by 2. The first shape, again, is a kite shape, where the diagonals cross and they make a 90-degree or right angle. To find the area, we want to multiply the two lengths, the two diagonal lengths. Going from left to right, the first part of the diagonal is 2, and the second part of the diagonal is 5. So the total distance, 2 and 5, would be 7. Multiplying by the opposite diagonal, in this case how tall the shape is. The first part of the diagonal is 3, the second part is also 3, so the total distance would be 6. Multiplying 7 times 6 would give us 42. And the last part you can multiply by 1/2 or divide by 2. 42 divided by 2 would be 21. And the units again, centimeters times centimeters, would be centimeters squared. So the area of the kite is 21 centimeters squared. The second shape and last shape for the section. Again, we have two diagonals making a right angle or perpendicular, so we can again multiply the two diagonals and then divide by 2. If we go from left to right, the first distance is 3, the second distance is 5, so the total distance would be 8. Multiplying the opposite diagonal, in this case is 4 and 4 again, so the total distance is also 8. 8 times 8 would be 64, and last part dividing by 2. 64 divided by 2 would be 32. And the units again are centimeters, so we'll have 32 centimeters squared for the area. Area of a rhombus. A rhombus is just like a kite with one extra definition. The diagonals are bisected. So again, similar to a diamond shape, the two diagonals crossing in the middle also make a right angle, and the new definition bisected means to cut in half, which means one side of one diagonal is equal to the opposite side of the other diagonal. In geometry, if you have the same hash marks, that means those sides are equal or congruent. And the other diagonal, which has two hash marks on both sides, which means the left-hand side is equal or the same as the right-hand side. The area of the rhombus is the same formula, 1/2 times the length of each diagonal. First question that we'll look at. The first rhombus, we're given two sides. The top half of the first diagonal is 4 inches, and the bottom half, or the left half of the second diagonal, is 5 inches. If you know the top side is 4 inches of a rhombus, that means the bottom half of that same diagonal is also 4 inches. And if the left-hand side of one diagonal is 5 inches, since they're equal or bisected, the right-hand side is also 5 inches. Finding the lengths of the diagonals, going from top to bottom, if it's 4 and 4, that would be a distance of 8. And multiplying by the diagonal going left to right, 5 and 5 would be a distance of 10. Multiplying, 8 times 10 would be 80. And the formula again, multiplying by 1/2 or dividing by 2 would give us the answer of 40. Each of these again are inches. Multiplying inches times inches, the answer would be inches squared. 40 inches squared. Second question, and last question for the section. The next rhombus, again, two sides are given. The top half of the diagonal is 7 centimeters, and the left-hand side of the diagonal is 3 centimeters. Again, if the top is 7, being bisected means the bottom will also be 7, and if the left-hand side is 3, that means the right-hand side is also 3. Finding the distances from top to bottom, 7 and 7 would be a distance of 14, and multiplying by the opposite diagonal, which again is 3 and 3, a total distance of 6, we can multiply 14 times 6. 4 times 6 would be 24, carry the 2, 6 times 1 plus 2 more would be 84, and the last part of the formula, divide by 2. 84 divided by 2 would be 41. And the units again are centimeters. Multiplying centimeters times centimeters would be 41 centimeters squared for the area of the rhombus. Title of the last section is more rhombus questions. Looking at the given rhombus, we know the left-hand side diagonal is 8 inches, and one of the outside lengths is 10 inches. Using what we know about rhombuses, if the left-hand side is 8 inches, that means the right-hand side is congruent or the same, which is also 8 inches. Also, a rhombus, just like a kite, makes a 90-degree angle in the middle. So if we want to, we can add a box to represent the 90-degree angle. To solve this question, we need the distance of the diagonal going top and bottom. If you look at the right-hand side of the rhombus, we know the outside length is 10, and we know one side is 8, but we do not know what the other side is. But if you're looking at the shape that is now made as a triangle shape, it is also a right triangle. A right triangle shape, we can use Pythagorean theorem, which we did in a previous section. Anytime you have a triangle with a right angle, you can use Pythagorean theorem, which again is a squared plus b squared equals c squared, to find a missing side of the triangle. The missing side, one of the legs, we can let be a, so a squared would stay the same. B squared is the other side of the triangle that touches the right angle. In this case would be 8. 8 squared would be 64. And C is the hypotenuse or longest side, which is across from the right angle. In this case is 10, or 10 squared would be 100. Solving for A, we can subtract 64 on both sides. So A squared equals 100 minus 64 would be 36, and taking the square root on both sides, the value of A would be 6. A again is the last side of the triangle, so if we add a 6 to our diagram of the rhombus, the top half of the diagonal is 6, and since it is a rhombus, the bottom half of the diagonal is the same side, which would also be 6. To find the area again of the rhombus, the two lengths, the diagonals going left to right, 8 and 8, would be a distance of 16. And the diagonal going top and bottom that we found was a distance of 6 and 6, which would be a distance of 12. Multiplying those two diagonals, 16 times 12. 6 times 2 would be 12. Carry the 1. 2 times 1 plus 1 more would be 3. Adding the 0 and multiplying 1 by 6 and 1 times 1. Adding straight down, we'll have 192. 192 is not the answer to the question. Again, that's the diagonals being multiplied together. The last step for the rhombus is to multiply by 1/2 or divide by 2. Using long division, 192 we can put on the inside of the division symbol, dividing by 2 on the outside. 2 goes into 19, 9 times. 9 times 2 would be 18. Subtracting and bringing the 2 down. 2 goes into 12 6 times. Multiplying, there's no remainder. So the answer to the question would be 96. Looking back at the original diagram, the units were in inches, so the answer would be 96 inches squared. Few formulas and definitions for this section. The vertex, again, is the point where the graph turns around. The equation for that, x equals negative b over 2a. And we'll use the equation ax squared plus bx plus c. So a would be the number in front of x squared, b is the number in front of x, and c is the last number. To find what y is, we will solve. Once we find x, we can plug it in and solve for y. Second definition, the axis of symmetry. Axis of symmetry will be the same as the vertex. X equals negative b over 2a. Symmetry means one side of the graph will be the same as the other side. And the line that cuts it in half would be negative b over 2a. And the last definition for this section, the parabola will open up if a is greater than 0, and the parabola open down if a is less than 0. So if a is a positive number, the parabola opens up. If a is a negative number, then the parabola opens down. First question we'll solve. Y equals 2x squared plus 4x minus 5. To find the vertex, again we'll use the equation negative b over 2a. A is the number in front of x squared, b is the number in front of x, and c we'll get to in a little bit is negative 5, the last number. So negative b, middle number is 4, which would be negative 4. 2 times a is the first number, which is 2, so 2 times 2. 2 times 2 would be 4, 4 divided by 4 would be 1, and have a negative on there, so it's negative 1. This is what x is equal to for the vertex. To find out what y is equal to, we have to solve or take this number and plug it back into the equation. So y equals, plug a negative 1 into the x squared. Negative 1 squared would be positive 1, times 2 would be 2. Negative 1 for the x, 4 times negative 1, that would be negative 4. And minus 5 would stay the same. 2 plus a negative 4 is the same as 2 minus 4, that would be negative 2. And negative 2 minus 5 would be negative 7, which is what y is equal to. So our vertex, x equals negative 1, y equals negative 7. We can write that as a point, negative 1, comma, negative 7. The axis of symmetry, again, is the same equation. But it is just the x value, so it's just negative 1. And this parabola either opens up or down. Looking back at the equation, we have a positive 2x squared. If the x squared is positive, then this graph opens up. Last part will be to graph. If we have a vertex, -1, -7, -1 would be the x value, -7 would be the y value. The axis of symmetry will draw a dashed line straight down through the vertex. This cuts the graph in half, so one side looks exactly the same as the other. And this parabola opens up, which means it'll start at the top, curve down to the vertex, and then the curve on the right side looks the same. Try one more of these. Last question for the section. F of x is -x squared plus 4x minus 4. Again, find the vertex. The equation -b over 2a. In this case, b is positive 4, but -b makes it a -4. And 2 times a is a number in front of x squared. In this case it's -1, so 2 times -1. So we'll have -4 over -2, which is equal to positive 2. And -b over 2a is what x equals, so x equals 2. Find the y value. Y again is the same as f of x. We'll take the 2, plug it in for x, and solve for y. In this case we'll plug a 2 in, do the exponents, and then we'll make the answer negative. So 2 squared would be 4. That minus makes it a -4. 2 times 4 would be 8, and minus 4 stays the same. -4 plus 8 would be positive 4, and subtracting the 4 on the end would be 0. Again, that's the y value, so y is equal to 0. Our vertex, again, we can make a point. X is equal to 2, y is equal to 0, so our vertex would be 2, 0. The axis of symmetry, again, makes the line or graph symmetrical. It's the same value as the vertex. In this case it's 2, but it's just the x value, x equals 2. And the graph can either open up or down. Looking back at the equation, if it's a -x squared, negative values are less than 0, so this graph will open down. Graphing from here, we can draw the xy axis. The vertex is 2, 0. The x value would be 2, the y value would be 0. The axis of symmetry, again, is a dashed line, goes down the middle of the graph. This graph opens down, so rather than a curve that opens up, the curve will open upside down. And that'll be our graph for the equation. Last section today is titled More Graphing. First equation is y equals 2x squared plus 4. Same steps as before. We'll do the equation -b over 2a, find the vertex, and then we'll graph. B again is the middle number in front of the x. There is no x in the middle here, so b is equal to 0 over 2 times a, which would be 2 times 2. 0 over 4 would be 0, which would be our x value. Find the y value, we'll plug 0 in. 0 squared would be 0, times 2 would still be 0, adding 4 to that, our y value would be 4. So for this question, our vertex, make it a point. X is 0, y is 4, that would be 0, comma 4. The axis of symmetry, again, is the same as the vertex, just the x value though, not the y value. X is 0, so our axis of symmetry is x equals 0. And the direction either opens up or down. Looking back at the equation, positive 2x squared. If it's positive, the parabola opens up. Graphing this question, we have a vertex of 0, 4. 0 would be in the middle, and we can go up 4 spots. The axis of symmetry is right down through the vertex, a dashed line, this time on top of the y-axis. And the direction's up, so we'll have a parabola that curves through the vertex and opens up. Last question for this section. F of x equals negative 3x squared plus 6x plus 5. Again, we'll do the same equation, negative b over 2a, to find the vertex. B in this case is a number in front of x, which is 6. The negative makes it negative 6. And 2 times a is the first number, which would be negative 3. We'll have negative 6 over negative 6, which is equal to 1. So the x value of the vertex is equal to 1. Plugging the 1 into the equation. 1 squared would be 1. Negative 3 would stay the same. 6 times 1, 6 would stay the same. And plus 5. Negative 3 plus 6 would be 3. Plus 5 more would be 8. So our vertex for this question would be 1, 8. Graphing. We can do our axis of symmetry. Is x equals 1, and the direction also before we graph, we have a negative 3x squared, so this graph opens down. Our vertex 1, 8. Axis of symmetry goes down the middle, and this parabola opens down, so we'll have a U shape that opens downward. And that would be the graph for the equation.